Ladies and gentlemen, today we're going to talk about the standard form of a quadratic equation, okay, and then we're going to talk about how we're going to go back and forth between the standard form and the vertex form, because there's good uses for both. Let's think about this before we start. What are the things we can do with a quadratic equation if it's in standard form? You can what?
You can factor it out.
Factor it out and find the solutions, or what's the other synonyms? Zeros, which are also the what? Intercepts, right? The x-intercepts. So in standard form, we need it for that. Vertex form, what do we prefer vertex form for?
Finding the vertex.
Finding the vertex, and what else? What do we do when we find the vertex? We're usually maximum and minimum, and what else are we doing? Usually if we're looking for the vertex, or I give it to you. What did you do for homework?
Oh, graphing it.
Graphing them, okay? So the standard form is really good for solving, okay? So when we get into our word problems and stuff, standard form is better. Not for every word problem, but for some of the word problems. And it's also easier to find your x-intercepts or your solutions. The vertex form is obviously super easy to find the vertex, which will sometimes be the answer to your word problem. And two, it's easier to graph in vertex form. So we need to look at both and how we can flop back and forth between the two. So we're going to be doing that and a lot of word problems in this section. So the graph of a quadratic function is what shape? U. Okay, and it's called a?
Parabola.
Spelled parabola. A parabola. But if you're trying to spell it out, spell it parabola. All right, the line down the middle of the parabola is?
Axis of symmetry.
Good. Okay, which you can graph a quadratic equation in standard form. There's just a lot more steps to it. So, I mean, honestly, you guys already know how to graph it in vertex form. So, why really bother with the standard form, to be honest? What would be like some of the things you would need to graph it? What are some of the important parts? Well, look at the picture you see here. What's the bottom thing called? The vertex. The vertex would be important. What else would be important in a graph? Y-intercept and x-intercept. Okay? And then, since parabolas are symmetric, the axis of symmetry would also be important. Again, like I said, you can graph them in standard form, but what you'd have to do is locate for me the vertex. There's the vertex formula, we're getting there. Then you would have to locate the axis of symmetry, which is on the vertex, so it's not that bad. You'd have to find the x and y intercepts, and then plot that stuff and use symmetry, and then you're going to get it. So it's a lot more work than the other way I showed you, but it is possible. All right, the highest or lowest point on the parabola is your vertex. If the parabola opens upwards, so if it's a U shape, the vertex is going to be the lowest or the minimum value. And if it opens downward, so it's upside down, it's your max value. So if you look here, here's lovely pictures. Here's max, there's the min. All right, so because so far we did maxes and mins on the graphing calculator, but we haven't done them by hand yet. So there's one way we can find the max or the min. So I want you to just kind of review here of our transformations. Tell me how the graphs are related. So how is 1/2 x squared related to x squared? What does this do?
Horizontal stretch.
So let's just use this. Is it going to be thinner or wider?
Wider.
So it's going to be a fatter or wider graph. Okay, what about 5x squared? Thinner. Yeah. I know you guys are using the nice thick words. But we can go pretty basic here. All right, what about the next one?
Upside down, down 3.
Right. And how about the last one?
Down
left 2, right down 3.
Left 2 down 3.
Left 2. Down 3. Remember, X lies, Y tells the truth. Alright, so here's your vertex form. This is pretty much what you're familiar with for graphing. You just didn't know it was called vertex form. It was like kind of like our function shift form. So again, H is your horizontal movement. K is your vertical movement. And A would be that number in the front.
It's like the horizontal shift.
So it's A like AX squared. So it's going to tell you, is it going to be thinner or wider?
It's like the slope.
Yeah, I mean, curves don't really have slopes, but yeah. Okay, now, notice this is X minus H. Okay? The standard, or the vertex form is in X minus H because if it's X minus H, okay, your vertex is going to be a positive X value, right? Because X lies. That's why that one's the standard form. So here you can see your vertex. Your vertex is going to be whatever H is and whatever K is. If your A value is positive, it's going to open up. If your A value is negative, it's going to open down. So if your A value is positive, you're going to have a minimum value. If your A value is negative, you're going to have a maximum value. So we're going to take the standard form, and I want you to switch it into vertex form. Tell me what the vertex is, and then talk about what the shift is. Because currently, right now, can you see what the vertex is? No. Okay, can you tell me what the shift is, the way it looks right now? No. We would have to do about 4 or 5 steps in order to graph it. Here comes in another beautiful application of, I'll have you guys figure it out. If I want it to look like this, right? What does this remind you of?
Oh, completing the square.
Completing the square. Here is our second application of completing the square. Yay!
Oh,
No, never.
never done.
Okay, so
Never forget completing.
this is a little bit different. First of all, when you're completing the square, the first thing you know is what?
Subtract the center. Oh wait.
Do ever to
Set equal to 0.
Well, yeah, well,
isolate
What?
the X squared?
yes, isolate the x squared. Is x squared allowed to have the 2 in front of it when you're completing the square?
No. Oh, you have to divide
No.
it.
So, now, yes and no. We do have to divide by 2. When we complete the square, we only take the x squared and the x portion of it, correct?
Yeah.
You still with me? Does the 7 work on my completing the square?
No,
What do we
no.
usually do with the
Move
7?
it to the other side.
Move it to the
So
other
we just
side.
have to keep it
However,
parentheses.
if we're writing an equation, do we want the 7 on this side?
No.
Parentheses.
Yeah, parentheses, we're going to have them hang out. So I'm going to remove the 2 from here and here, which means essentially I'm going to factor that 2 out. Okay, you still with me?
Mhm.
So when I factor that 2 out, I'm left with 2 times
X squared.
plus 4x right now. For completing the square, remember our magic number. Okay.
Then
Now, before we get to the magic number, 7 is still here, right? I still have my plus 7. Now, usually what we do is we put the magic number on the right and the matching magic number on the left, correct? However, do I want anything on my other side? No. So, if I'm doing the same thing, if I'm adding something here, what would I have to do to keep it balanced?
subtracted on the
Subtract it over here. Okay? Because, for example, if I added 2 here and I subtract the 2 there, have I really done anything to my equation? No. So this time around, you add a magic number inside and then doing the opposite on the outside so it keeps it balanced. So like this was still your F. We're adding a number to it and we're subtracting a number from it so it stays exactly where it was. So what is my magic number?
2, 4.
4. All right, now, here's the problem. I'm not putting a 4 there. Why wouldn't I put a 4 there?
That's not the number you. It's 2, right?
It's 8.
8.
It's 8. Why?
Isn't it 2 plus 2?
Right. So what you wanted to do is come back to this original equation, right? So I'm just going to show you real quick. What happens here is, if I was going to put the 4 here, if I wrote it all back out this way, right, I would have 2x squared plus 8x plus 8, and over here I only have plus 7 minus 4. So is that balanced?
No.
No. So it's a 4 is my magic number, but when it comes out of the parentheses, what number is it actually? 8. So what we're going to do is put a minus 8 to keep it balanced. So when I complete my square, it's 2 times what quantity?
Excellent.
Bingo. And then I do 7 minus 8, which is
Minus 1.
minus 1. And there is our beautiful vertex format. And I could easily graph that. What are my shifts?
It's gonna equal.
I'm down 1, right?
1, left 2.
Left 2,
And
and thinner. Cool. So it really wasn't that bad.
I don't know.
I think this is faster than doing all the steps to graph in standard form.
Okay.
Because again, if we were going to graph in standard form, we'd have to locate the vertex and draw it in. Then we have to do the axis of symmetry and draw it in. Then we have to find the intercepts and put them in. Then we need to use symmetry to find my 5th point, and then I can actually graph it. That sounds like a lot of work, doesn't it? Okay, so since we already know how to do it this way, we can simply just complete the square, put it in the vertex form, and graph it real easy. How about the next one? So again, yeah, it's already nice.
The first one has to be.
Right, so do I even really need to complete the square?
No.
Isn't it already completed?
Yeah.
Okay. So I'm not even going to bother. What is it? It's already a square.
That's what it was.
Horizontal.
And all it is a what?
Left shift 1.
Which direction? Left. That's it. All right. Oh, I didn't do the vertex in problem 4.
Is that one?
All right, let's do the vertex here. In this case, what's my vertex?
1 0.
Try again.
0 1.
Try again.
No.
Wait.
Wait.
-1.
Negative 1, so I move to the left one, right? 0. Remember your h is this number, but that's when this is minus. So since this is plus, it would have to be -1. Does everybody follow that? Remember your x lies, your y tells the truth. So if x lies, it would be -1. And there is no y, that's why it's 0. If you go to the problem before that, I forgot the vertex. Let's do the vertex over here. What was our vertex here?
-2 -1.
-2, -1. Again, x lies, y tells the truth. Okay? All right, so different kind of problem. What if I give you the vertex and I give you a point? How are you going to write the equation? I want it in vertex form. That's nice. All right, so f of x is equal to a times x minus h quantity squared plus k. How can I use that to help me figure out the equation?
Fill in the
Fill in this stuff. What am I filling in? H and k. So this is h and this is k, right? And then what do these represent? What are these 2 points? What? Not a and x and y. They're x's and y's, right? It's a coordinate pair that's on that parabola. So I can fill in h and k and x and y, and the only thing I'm missing is a. That's the only thing you really have to solve for to write the equation. Okay. So y is a times x is 3 minus h squared plus k. So -6 is equal to 3 minus 1 is 2. 2 squared is
4.
so 4 times a plus 2. So -8 is equal to 4a, and a is
Negative.
-2. Don't stop there, though. The question is, I want the equation, so my equation would be f of x is equal to, my a was -2, times,
X
uh-huh,
minus 1
Uh-huh.
squared
good.
plus 2.
Plus 2, beautiful, that's it. So this is very similar to when you were doing, like if I gave you a slope and a point and I asked you to write the equation of a line. And usually we were looking for the y-intercept. Same concept. We're plugging in our vertex and our point, and we're looking for the a value this time. Okay, questions? Again? Oh, but what did I write this time? Womp, womp, womp. I asked for the standard form. Do we know how to directly put it into standard form? No, so what should our game plan be? Put it in vertex form and then multiply it out and make it look like standard form. Okay, so same process here. Let's plug the stuff in. This is my h and my k, my x and my y. So -7 is equal to a times 6 minus 4 squared plus 1. 6 minus 4 is? Squared is? So 4a plus 1. Look at that. I made another one with an a value of -2. All right, so the equation I have so far -2 times x squared plus 1. Okay, so then what do I do now?
Solve.
Before I distribute, I need to FOIL it first. All right, so it's 2 times x squared minus 4x is minus 8x plus 16 plus 1. Now I have to put that -2 in. So it's -2x squared plus 16x. And then that's a -32. -32 plus 1 is?
31.
-31. And here is your standard form of that equation. So we can do both. Questions? Okay. Example number 5 is identify the x-intercepts. So if I want to identify the x-intercepts, what am I looking for?
X.
The zeros, which means what am I doing?
That's 0.
Just solve it. Now, I do not like having my x squared negative, so I'm going to flip-flop sides here. So x squared minus 6x plus 8 is equal to 0, and we can just factor it. How does it factor?
Minus 4.
Minus 4 minus 2.
Yep, so x is 4, 2, but the question says what's the intercepts? So we should list them out like intercepts. So it's 4, 0, and 2, 0 are my intercepts. Questions?
Did you just see how many it is?
Yeah, I added everything or subtracted it to the other side.
Okay, gotcha.
I don't like my x squared being negative. Or you can think of it as I multiplied everything by -1.
Okay.
All right. Next part. Minimums and maxes. This thing right here, your minimums and maxes occur at your vertex, right? We already talked about that. So this is called your vertex formula, -b over 2a. Okay, that's kind of adapted from like your vertex form a little bit. Okay, that's always going to give you, if you're in standard form, that is going to give you your vertex every time. Or at least I should say the x coordinate of your vertex. How would you find the y coordinate of your
Plug
vertex?
it in.
Plug it in. Good. All right, so determine if f of x is equal to 3x squared minus 4x plus 6 has a max or min, and then find it. So,
-3 over.
well, hold on. Is it a max value or a min value?
Max. Min.
Min. Again, it's determined upon the a value. The a value is positive, so it is a minimum. Okay. And we're going to find it. So x is -b, which would be positive 4, over 2 times a,
which is
4 over,
6.
which is, oh gosh, you really gotta simplify your fractions. You were killing me. That was the unsimplified fractions. All right, so 2/3 is your x value, and then what do we have to do to find y?
X equals that plugged in.
Plug that bad boy in. Oh, I love reviewing fractions. And just know, you can always just plug it right into your calculator. You don't have to do it by hand. All right, so this would be 4/9. So 3 times 4/9, 1, 3 is 4/3. Minus 8/3. Plus, what's that, 6? So 6 is how many thirds? 18/3. Put it all together, you get, you got it. So the answer for the vertex would be 2 over 3, 14 over 3. All right, questions?
Nope.
Just kind of bringing together a bunch of stuff here. Yes, put it all together. It's like a puzzle. I love completing the square.
What's going on with that?
Oh, and now we have the word problem. Yay!
Oh.
They're not as scary as they look.
But they're words.
No, they are.
We actually already answered this question. This exact question is on a set of notes that we've already done. We just answered the question with a calculator. Now we're going to do it by hand because now we know how to do it. So, if you remember from the last time we read the baseball question, and does the baseball clear the fence? Okay?
Yeah.
There's a lot of mumbo jumbo in this question, and the reason why I like to give this question is because I want you to be able to pick out what's important. What would be important in this question? The f of x, right? That part's important.
And what x means. So x
What
is
x is, right? X is the horizontal distance, and
Max.
f of x is the height of the baseball in feet, and we want the max. Which, if you look at this, it says max. Shouldn't this have a max?
Yeah.
Because the a value is negative, right? If you're looking for a max, you're really looking for the what of the parabola?
the highest point.
The vertex. We have a vertex formula. So x is negative b over 2a. So, what's my b value? 1. So negative 1 over 2 times negative. 0.0032. All right, somebody plug that in and give me an answer. It actually works out to a pretty number. Well, I guess it's not pretty. I believe it's a decimal.
10,000 over 64.
This is a word problem. Give me the decimal.
Oh.
That's the only time we're allowed to break that rule.
Oh yeah.
What is it?
0.064.
Well, positive.
No, negative.
Yeah.
Well, then you have to do 1 divided by that number. Yeah.
Puzzle.
10,000 divided by
So we're doing negative 1 divided by negative 0.0064.
So we're just taking away the negative.
Well, negative and negative, they cancel. Come on, guys, it should be 100 and something.
Give me.
156.25.
That's what you got? Can anybody confirm?
What is it?
I knew it was 100 point something.
Wait.
All right. So what does that represent?
The height.
The horizontal.
The horizontal distance. X is the horizontal distance. This is X, isn't
Yeah,
it?
plug that in.
So we need the height because we want to know what's the maximum height. So yes, we need to plug that back in. So if you plug in your 156, so we have negative 0.0032 times 156.25 squared plus 56.25 plus 3. You guys plug that in for me. And tell me what you pop out with.
Need some more.
Oh, I got them. Thank you. I believe it's also 100 something. If that helps. maybe it's 180. 81?
Yeah.
I was close. Nope, it's got 8 in there. 81.125, and that's in feet, and that's your maximum height. Don't forget the right feet. Okay? So really, it looked like a scary word problem, but it was really pretty simple.
Yeah, because there's like 2 feet above the ground at a velocity of 1 feet per second.
That was a lot of extra bogus information you didn't need.
Fake news.
It was information that the person who created the parabola's equation needed,
Yeah.
so that all those numbers went into that equation, but we didn't need them for our purposes. All right, a soft drink manufacturer has a daily production cost of that, where C is the total cost in dollars and X is the number of units produced. Estimate numerically the number of units that should be produced to yield a minimum cost. So why should it be a minimum cost?
Because the A
The vertex.
A is positive, so it's going to be a minimum number. Be careful, guys. This is your A.
Why are they doing that?
It's very off.
It would be like
It's very off. All right. So again, if we're looking for a minimum, what do we need?
Throw them off.
So we need
Someone put 70.
Minimum.
Yeah, right.
X.
Vertex. X equals negative B, so that's 120 over 2 times A, which is 2 times 0.55, which is essentially 120 divided by, 1.1, which gives me
what was it?
120 divided by 1.1.
109.09.
All right. 109.09 repeating? All right, so now we need to answer the question. We want to know how many units I need to produce. What does that 109.09 repeating represent?
Number of minimum units.
The number of minimum units.
So do I need to plug that in?
No.
No! Now answer the question.
Oh. the number.
How many units?
109.
109 units, good. So sometimes, when you just get X, that is your answer. You have to be able to read the problem, decipher what X is and what f of X is, and figure out which answer they want or do they want.
Would it be 110 because you can't have 0.09?
You can't have 0.09, but remember we want a minimum cost. So actually, if you plugged in 109 and you plugged in 110, the cost is going to be less with 109 than 110.
Yeah, but that wouldn't be possible because
It'll be. Okay. Questions? Okay. So honestly, most of the quadratic word problems are going to be pretty easy like this. The harder ones are asking you, like, for example, when would this object, like, so for example, when would the baseball that was hit the ground? So think about this. Here's your ground. Here's your baseball coming off the bat, and it's going to hit the ground. It's still taking a parabolic
So is it going to be like the X
motion.
intercept?
Yes, it'll be the x-intercept, which means instead of using vertex formula, what are you going to do with the quadratic equation?
Plug it in.
Plug in 0 for f of x and solve it. So you're going to factor or use quadratic formula. That's it. That's really as hard as these quadratic equations word problems get.
Okay.
That's it. All right, so there's your work. You're doing 54, 55, 56, and 57.